Now today I want to derive the quadratic formula using the completing the square method. How do they come about? This is a quadratic expression is in this form: a raised to the power x squared plus bx plus c equals to 0, whereby a, b, and c, they are all constants. And this is our quadratic equation look like. So now we have ax squared plus bx plus c equals to 0. And we want to derive the quadratic formula using completing the square method to get the formula. And how do we do that? First of all, we have to make sure that the coefficient of x squared here is unity. Coefficient of x squared here is unity. Then what do? We divide through by the coefficient of x squared. Divide through by the coefficient of x squared, which is a. Therefore, we have ax squared over a plus bx over a plus c over a equals to 0. By the time you make it 0 over a, you are still going to have 0. So this now is going to give us x squared plus bx over a plus c over a equals to 0. Now this is in terms of x, this is in terms of x, and this is just ordinary constant. No any variable with it. The second step is to make sure that the constant part of this quadratic equation move to the other side. And why are we doing that? Is to make sure that one side is a perfect square and the other side is just a constant or number. Now, just move this to the side, say x squared plus bx over a equals to c minus c over a. Now the next step is to take the coefficient of x here, which is b over a. After taking the coefficient of x here, we multiply it by 1 over 2, then square everything. And what do we mean? We're going to have x squared plus bx over a plus, we're going to add it to both sides. The coefficient of x is b over a. So we have b over a, so b over a, multiply by 1 over 2, then square it. Exactly what you have here, we're going to add it to the other side too. Equals to minus c over a plus b over a multiplied by 1 over 2, everything squared. And from here, this is going to give us x squared plus bx over a plus b, we have b over 2a all squared equals to minus c over a plus b over 2a all squared. So this is already a perfect square. This is already a perfect square. So by the time we try to bring them together, so we're going to have x plus b over 2a all square. By the time you expand this, we're going to have exactly what is here. Then equals to minus c over a plus b squared divided by square of all this, which will give us 4a squared. So we already have that 4a squared. So I can write this way. So x plus b over 2a all squared equals to b squared over 4a squared minus c over for minus c over a minus c over a. And here we have x plus b over 2a all square equals to, if you take the LCM here, our SN is 4a squared. So therefore, you're going to have b squared minus, so you know we already have 4a squared elsewhere. 4a squared before a squared 1 multiplied by b squared, a will cancel a, so remain 4a multiplied by bc, so we have 4ac. Now from here now, we need to remove this bracket here. And in the case of removing the bracket, so we're going to have x plus b over 2a equals to plus or minus square root of all this value here, which is b squared minus 4ac divided by 4a squared. Now, making x the subject formula, which means db over 2a will move to this side. And in that process, we're going to have s equals to minus b over 2a, move it out, and then we have plus or minus square root of b squared minus 4ac divided by, you can see the square root is not affecting this denominator because I'm going to take the square of 4 is 2, the square root of 4 is 2, and the square root of a squared is definitely a. Now here we have x equals to, taking the taking the LCM, so we know that the LCM is ordinarily 2a, and therefore we're going to have minus b plus or minus square root of b squared minus 4ac. This is the quadratic formula for solving quadratic equation. S equals to minus the plus or minus square root of b squared minus 4ac divided by 2. We use the quadratic formula again, using completing the square method to get our answer.